Hello, everyone, and a very good morning. Distinguished delegates, presenters, and participants from SAARC member states and other regions around the globe, it gives me a great pleasure to extend you all a very warm welcome on behalf of the SAARC Energy Center. I'm very thankful to all of you for joining us in this video conference to disseminate the study on assessment of industrial readiness for manufacturing of battery electric vehicles in the SAARC countries. I'm Dr. Tanveer Ahmed, and I'm working at SAARC Energy Center as Program Leader, Technology Transfer. I shall be moderating today's video conference. Ladies and gentlemen, electric vehicles are gaining popularity throughout the world. They are becoming the preferred vehicle type by both consumers as well as governments, which has pushed the automotive manufacturers into EV development and technology innovation. Mass adoption of battery electric vehicles have been hailed as a significant driver, bringing reduction in two of the most threatening issues facing the developing countries. That is the pollution levels and oil import bills. SEC conducted the study on assessment of industry readiness for manufacturing of battery electric vehicles in SAARC countries in 2019. The purpose of this video conference is to create awareness about BEVs and get feedback for value addition in the study. Ladies and gentlemen, I would now like to invite Dr. Shoaib Ahmed, Deputy Director, SEC, for his opening remarks. Over to you, sir.
Thank you, Tanveer. Dear participants and presenters of the video conference, friends and colleagues, Assalamu alaikum and a very good afternoon. I, Dr. Shoaib Ahmed, welcome you all to this dissemination video conference to disseminate the research report regarding assessment of industry readiness for manufacturing of battery electric vehicles in SAARC countries. It's an honor for me to open the discussion on this important technical and very popular topic, which is directly associated with the increased deployment of cleaner transportation systems in SAARC and the betterment of its 2 billion people as well as the environment around them. Dear participants, the SAARC Energy Center is a regional institute on energy and a technical arm of SAARC organization on all regional energy matters and associated fields. It is our endeavor to translate the energy vision of the SAARC leadership into the betterment and prosperity of the region. For that, we take all possible steps within our mandate and resources. Such steps also include the capacity building of professionals of the member states on the modern and useful technologies. The center started its operation in year 2008. During the last 12 years, the center has emerged as a vibrant and effective SAARC institute, which has played its role in all regional level energy initiatives. Until now, the center has carried out 140 plus interventions. The reports of these interventions are available on center's website free of cost to all living in or outside South Asia. Dear participants, battery electric vehicle demand is rising globally. Buyers are mostly attracted to battery electric vehicles based on several factors such as cleaner technology, saving on fuel and maintenance costs, pleasing driving experience and robust performance. In addition, electric vehicles have a significant positive impact on energy and environment. These can assist in improving efficiency in electricity sectors through storage and demand response services. The use of electric vehicles will reduce air pollution and countries spending on imported fossil fuels, which in case of majority of SAARC countries is imported at the expense of precious foreign exchange reserves. In coming years, it is expected that share of electric vehicles will increase in the transportation sectors of all SAARC countries. Therefore, it is important that local industries of the SAARC countries should be fully geared up for the induction of electric vehicles. This research report is a step in this direction. Dear participants, recognizing the usefulness of electric vehicles and associated challenges, the Sark Energy Center decided to chart a course towards a sustainable and clean future based more heavily on transport sector's electrification. Accordingly, series of research studies was related to electric vehicles were carried out in the last couple of years. This study was also undertaken in year 2019. A workshop to disseminate the findings of the study was scheduled in this year in India, but due to ongoing pandemic, it's not possible to conduct the same. Therefore, this video conference is being organized to disseminate the contents of the research report. Dear participants, this research report is a result of substantial investment in time, efforts, and dedication of the experts of the Sark Energy Center, authors, and the peer reviews. I would like to acknowledge their contribution in hope that you will enjoy and appreciate the dissemination of this knowledge as well as benefit from its findings. Dear participants, in this video conference, we have resource persons from Lahore University of Management Sciences, Pakistan, Indian Institute of Management, Bangalore, India, and experts from CRISIL of India. They shall disseminate the research findings and share their knowledge and experience through presentations and interactive discussions. I fully acknowledge the great cooperation and support extended by all of them. I also thank them for sparing their time and knowledge for this video conference. In the end, I once again thank you all for joining this video conference and shall request you to feel free in expressing your opinions and suggestions for the improvement. With this, I declare the session open and wish you all a very comfortable learning and knowledge sharing. May I request Dr. Tanveer Ahmed to take us through the agenda of the video conference. Thank you.
Thank you so much, sir, for your remarks and for being here with us today. Dear participants, today we will have speakers from LUMS Pakistan and IIMB India, as well as CRISIL. They are the authors and peer reviewers of the study, and they will be talking about different aspects of battery electric vehicles and the study. You will have the opportunity to ask questions to presenters by typing your questions or clicking to the raise hand option in the attendees pane of the main window of GoToWebinar software. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of each presentation. Additionally, you will also have a chance to share your views in the knowledge sharing session of the webinar. Well, ladies and gentlemen, let's move to the technical session and start with formal presentations. Our first presenter is Dr. Muhammad Shakil Sadiq Jaja, who is an Associate Professor of Operations and Supply Chain Management and Director of Executive MBA Program at the Sulaiman Dawood School of Business at Lahore University of Management Sciences, Lahore, Pakistan. His research work has been published in top-tier international journals. Dr. Jaja has participated in Global Colloquium on Participant-Centered Learning at Harvard Business School. He has also received doctoral fellowship of Association of Management Development Institutions in South Asia. Dr. Jaja did PhD in Operations Management, MS in Total Quality Management, and BSc Honors in Mechanical Engineering. Prior to joining LUMS, Dr. Jaja has also worked with IBA Karachi, PNRI, PIA, Atlas Honda, and Dawood Hercules Chemicals Limited, Pakistan. Over to you, Dr. Jaja. Doctor, yes, you are audible now.
Okay, thank you. So thank you, Dr. Tanveer, for opening up the session, and also thank you, Dr. Shoaib, for your remarks and introduction about the report. So I hope that you can see my screen now.
Yes, we can. Yes, we can.
Okay. So I have put it on full screen, so only I think now the full screen as slideshow will be visible.
Yes, sir. Yes.
Okay, so then I can go on. Dear participants, thank you very much for joining for this session. I am Shakil Sadiq Jaja, Associate Professor at Business School in LAMS. This report that I'm going to present partly is is a joint work by. I'm just trying to adjust the screen on my end so that okay. So I'm fine now. So this is a joint work by Dr. Zahoor Hassan, myself, and Professor Haritha Saranga from Indian Institute of Management, Bangalore. She will also be joining us after my presentation today. This research was mainly triggered and funded and supported by SARC Energy Center Islamabad, and we are greatly thankful for their support in this research and also for lending the funds for supporting this research. So what I'm going to focus today is the Pakistan and the global aspects of battery electric vehicles and their manufacturing. So I'll begin from what is going on globally on battery electric vehicles as far as manufacturing and value chain issues are concerned. Then I'll focus on Pakistan's development on battery electric vehicles in manufacturing or otherwise in the value chain. And then some key points that we should take away from this understanding our research on Pakistan's battery electric vehicles value chain. So to begin with, I would like to begin with the ideas or the objectives behind this research. So basically, when we started this research, the main objective was to collect the insights from Pakistan's auto industry and look at the potential of this industry if it has to move forward in battery electric vehicles. And then also understand where do we stand currently and what are the key areas where there is a potential in this industry if battery electric vehicles are manufactured or maybe their parts are manufactured in Pakistan. So what are the potential areas, which areas can become sources of strength for Pakistani industry, and also recommend some actions or improvements that can help this industry move forward positively in battery electric vehicles manufacturing in Pakistan and India. So these were the main objectives that we started with in this research. So our approach was that we'll look at the global trends first. So we'll look at what is happening globally in those countries and regions which are leading in electric vehicles adoption on consumer side as well as manufacturing or the supply side. So we started with understanding what is going on globally on this, and we started from understanding the main global trends. So as Dr. Shoaib earlier pointed out, and it was also pointed out by Dr. Tanveer, that electric mobility is now expanding globally and with a rapid pace now. I can safely say it's not linear, it's exponential now. So in 2018, for example, the global fleet of electric vehicles exceeded 5.1 million, which was more than 2 million increase in compared to the previous year, almost doubling every year. So this is the trend that we are seeing in electric vehicles adoption. And within the electric vehicles, there is this category of battery electric vehicles. So electric vehicles have different types, and the one that we focused on is battery electric vehicles because this vehicle does not have internal combustion engine. It only bases on battery and motor to run itself. So this is purely based on battery and motor, and accounts for 64% of the world's electric car fleet. And in this category and otherwise also in electric vehicles, China is leading the world in the number of vehicles they have, and followed by Europe and the United States. Within Europe, if you look at Germany, this year, EV's electric vehicle outlook report 2020 of International Energy Agency shows that Germany has taken the top position in number of electric vehicles sold in 2019. Earlier, this position was with Norway. So we see that you see different countries are speeding up in their adoption of electric vehicles. I'll show you more details as we go forward. And also there is an ongoing campaign on which is commonly known as Vision 30 at 2030. So meaning that 30% of global vehicles sales will base on electric vehicle sales by 2030. That's a target that some countries have set up for themselves, and they are China, Japan, Finland, France, Netherlands, Sweden, India, and a couple of more. So this campaign is ongoing, and more countries are joining. Hopefully, Pakistan will also be one of them in years to come, and that's where the direction is. If you look at the global trends, so China, you can see that has the highest number of electric vehicle sales per year. On this chart, on left hand side, you will see that new electric car sales in numbers, in absolute numbers. So you can see that China is leading there by far, by a great margin, actually, compared to United States, and then also Europe. If you look at individual countries, I mean, so China, United States, they are big economies. If you look at comparably big economies, and also big geographic spaces as well. But if you look at smaller geographic spaces or smaller countries in terms of population, there you see Germany, United Kingdom, France, Canada, Korea. There also you see a trend of adoption of electric vehicles. Now, if you look at the right-hand side of this chart, this shows the percentage electric car market share. There also you will see that Germany is, within Europe, Germany is leading, has the top position this year, Norway in the previous year. So we see that a lot of progress in the adoption of electric vehicles across the world. As earlier pointed out, these are some of the commonly quoted benefits of why electric vehicles are being adopted. They are energy efficient, 3 to 5 times more efficient than their equivalent internal combustion engine based vehicles. They reduce oil bills, and that is particularly important for countries like us who import oil, and oil import is a big part of their expense. This is also important from air pollution standpoint. So if the energy mix or the energy supply of the country is rightfully, appropriately managed, electric vehicles can be a great source of reducing the air pollution on the road, and also greenhouse gas emissions. And finally, noise reduction, particularly in 2- and 3-wheeler categories that are very dominant in countries like Pakistan and India and South Asia in general. So a lot of noise and can be reduced, and pollution can be reduced by switching those 2-wheelers, 3-wheelers into electric vehicles. So these are some of the benefits that are that attract attention towards electric vehicles. So, excuse me. So global trends, if you look at the regulatory drivers of diffusion, there are different type of drivers which governments or regulatory institutions are using to enhance adoption of electric vehicles. So for example, fuel economy standards, CAFE, known as CAFE, which is corporate average fuel economy, and similarly zero emission vehicles mandate in US are examples. So they ask the manufacturers of vehicles, automobile manufacturers, to bring the emission level of their vehicles to low level, which becomes difficult to be met by internal combustion engine technology. So therefore they have to move towards electric vehicles. So this is an indirect way of pushing the manufacturers to move into electric vehicles. Similarly, fiscal incentives such as tax credits, subsidies to manufacturers are also encouraging them to move into electric vehicles. Economic instruments, for example, free registration or license plate fee removals, lower toll, or access to free parking, etc. They are also driving individuals to buy electric vehicles. Battery technology is an important aspect of electric vehicles because that's the key. That's a substitute, a main substitute, I would say, in electric vehicles for engines, and accounts for 40% or 50% of the electric vehicle price sometimes. So there is a lot of incentive also going on into enhancing battery technology value chain. So similarly, procurement programs, governments are across the world, they are introducing large fleets of electric vehicles in different areas that they are operating in. For example, Shenzhen province in China is putting regulations in such a way that buses and bus operators are to become to have to use electric vehicles. So 16,000, for example, electric buses operate in Shenzhen. So it's the largest electric bus fleet in the world, perhaps. Similarly, Europe, Schiphol Airport, they have 100 electric buses, and there are so many different examples of governments pushing themselves and also the operators of different fleets being used by transportation in general in the city, and otherwise also to convert their fleet into electric fleets. And similarly, infrastructure support policies are there, which are encouraging buildings and parking lots to be suitable for electric vehicles. Adoption standards for charging infrastructure are being introduced so that consumers do not have to face different type of charging infrastructure, and wherever they go, they have a standard charging infrastructure that they can use. So these are all of the policies that governments are using to encourage a diffusion of electric vehicles. As I mentioned before, battery is a key thing in electric vehicles, and batteries prices are exponentially going down now. In last 20 years, they have gone down significantly, I would say drastically. So you can see this curve, which indicates the lithium-ion battery pack price in 2010, and then it is 6 times reduced by 2017 or 18, and now again in 2020 there are, every day you will see news coming on developments on batteries. Even a couple of days back, Tesla made an announcement which they are hoping will be key in bringing their cost further down. So all these developments are happening in batteries, and they are playing a key role in bringing the cost of electric vehicle down, and cost is a major barrier towards adoption of electric vehicles in general. So these improvements are basically coming from different sources. Battery production and chemistry is improving, that is bringing cost down. Increase of the sale of batteries are increasing. As a result, there are economies of scales for manufacturers, and they are also investing resources in developing better ways of production and manufacturing. That is bringing the cost down. Similarly, there is innovation, and there is simplification of applications of batteries in different vehicles. So that is bringing the batteries cost down. Digital technologies are being used that are aligning the user needs with the battery's design, and therefore there is an optimal use of the battery vis-a-vis the user's requirement. As a result, the battery's demand in general per user is going down, and therefore the supply going up, and in net effect, the price is going down. So, and similarly, there are improvements in lead acid batteries also going on. Lead acid is not the most preferred form of batteries in electric vehicles, but in developing countries, we'll see that some of the two-wheelers, three-wheelers are leveraging this technology still. So there are improvements happening in lead acid batteries also. And on the horizon, we see technologies like graphene technology and supercapacitor also coming, which will, I think when they come, they will completely take the battery question out of the equation in battery electric conversation, battery electric vehicles conversation. So those technologies are also on the horizon, and we might see them coming and completely changing the game for electric vehicles versus internal combustion engine based vehicles. So you can see that lithium-ion battery is growing on this right-hand side diagram. You can see that the contribution of lead acid-based battery is percentage contribution is going down, whereas the lithium-ion batteries percentage contribution in the global supply or application of batteries is increasing. And on the left-hand side, you can see that the main suppliers of lithium-ion battery in the world. Now, the next thing that we did was once we reviewed the global trends in battery electric vehicles and in battery technology, we looked at China more closely. We thought that China is the leader, and it's not a thought only, it's the reality that China, in terms of manufacturing electric vehicles or adoption of electric vehicles or the total fleet of electric vehicles, in many important ways, China is the leader in electric vehicles. So that's why we focused on China to understand that what is going on there and what is important to be picked up for our conversation in SAARC countries, and what is that we can learn from there. So with that spirit, we try to understand what was going on in China. So China is the biggest manufacturer of electric vehicles, biggest market also, approximately 3 times the US market. The number of vehicles sold are 3 times more than what are being sold in the US. They buy more than half of the world's new electric cars every year. More than 50% of the number of cars sold across the world are sold in the US, in China. Their target is that it would be 5 million EVs by 2020. They have introduced this new energy vehicles mandate, so which basically says that OEMs must earn credit to match 12% of their input. So 12% of the input should be based on electric vehicles. Roadmap. And they are now growing this target over years. So 2020 they have 7 to 10%, 2025 15 to 20%, and 2030 40 to 50%. So that's where they are targeting. While the world is targeting, while the rest of the countries are targeting 30% by 2030, they are targeting 40 to 50% by 2030. So clearly we see direction in adoption of electric vehicles in China and leadership as well. And also they are putting fuel economy standards for car manufacturers that, as I mentioned earlier, would push the manufacturers to develop cars or design cars that can give this amount of fuel efficiency. But this amount of fuel efficiency will be very difficult to achieve by internal combustion engines. So naturally, they will have to go towards electric vehicles if they have to meet these standards. So if we focus on what is going on in China as far as the manufacturing of electric vehicles and batteries is concerned, here are some important facts. So 26 million units of two-wheelers and three-wheelers in 2018, which is 25% of global stock of two-wheelers and three-wheelers. They are being manufactured in China. The domestic OEMs have 94% market share. So which basically says that 94% of the electric vehicles sold in China are made in China or manufactured in China. That's a great inspiration for countries in South Asia, and I'll come to this question later in this presentation. But since their manufacturing has now matured, now they are reducing incentives for manufacturing because cost of production of electric vehicles has already gone down, and now they are investing mostly in battery manufacturing, and 80% of global lithium supply in 2020 is coming from China, and this is almost 3 times. This has become 3 times in last 4 years. So it was 25% in 2016, and now it is 80% in 2020. So China is investing a lot of effort and resources in acquisition of and manufacturing of lithium and supply of lithium to the global battery supplying in the global battery supplying community. So as a result, the manufacturing cost has also gone down, and 90% of Chinese manufacturers are using lithium-ion batteries, which are manufactured in China. And one important factor, I think, that we can in South Asia also, and particularly Pakistan, we can get inspiration from, and perhaps we have been doing that in the past as well, is ask foreign OEMs to enter into joint ventures with local manufacturers if they have to do business in Pakistan. So, and they are doing this in China. So we have been doing in the past also, and it has been beneficial in many ways. But it has been my personal sense is that it has not been fully exploited in the past, and we need to see that how we can learn from what we have been doing in the past as far as the JVs of local OEMs with international partners is concerned, and how the benefit of that can be transferred more to Pakistan. So that's something that we can learn from there. So China's EVs, main EV, there are many important EV manufacturers, but the one which is most commonly quoted and the biggest one is BYD, known as BYD. It's the largest world electric vehicle manufacturer for past 3 years. Large revenues, 20% of market share in 2018. So it's vertically integrated and biggest. It has the biggest battery manufacturing plant in China, and we can see that why the vertical integration is needed here, because battery is the key resource in the supply chain of electric vehicles, and since currently the demand and the future of battery technology is not certain. So we can expect that original equipment manufacturers would try to vertically integrate towards their supply side to develop facilities for a reliable and large volume of supply of batteries. So we see this happening in China, vertically integrated supply chains owning OEMs as well as battery manufacturers. BYD is also a supplier of electric buses in North America, Europe, Latin America, and other countries. So, I mean, why I'm mentioning BYD is that, and there are others also that are important to look at, is that if one has to see what is going on in manufacturing in China, perhaps the starting point would be BYD to look at to understand how they are organizing their manufacturing. Now the next thing is that after looking at the global trends and what is going on globally in battery electric vehicles, we got some understanding of that what would a typical battery electric vehicles value chain look like. So here is our sense of how a battery electric vehicles value chain would typically look like. So you can see there are 2 rows, one above, one downward. So the below row you see this is basically a typical supply chain. So vendors and part manufacturers to regional equipment manufacturers to distributor and after sale service, uh, and then government policies. I think this should have been upwards. This is perhaps something I missed out. And then it is going to charging infrastructure and then recycling of the batteries. So you can see that if we were to understand the manufacturing readiness, we had to focus on upstream players only, which is basically vendors and original equipment manufacturers. And this supply chain is affected by many things which are happening around them, and enabled by or perhaps disabled by and supported by or unsupported by some important actors around them. So for example, government, energy supply, or mix of energy supply, a regulatory and legal framework, educational and research institutions working on technologies such as motor and battery management systems and so on. Technology providers who are international players would be interested and are interested in clearly in Pakistan's market, and India, for example, has already made some collaborations there. So financial institutions such as banks, they have an important role to play, and industry associations, how they take this technology and how they take it forward has important role in making the supply chain of electric vehicles work or not work. So this is how our sense of electric vehicles value chain is organized. So in this research, then we focused mainly on vendors and original equipment manufacturers, because they are the key players who are going to play important roles in manufacturing of electric vehicles in Pakistan. And then those two things, these two, I mean, the vendors and original equipment manufacturers, we focus on them from three different perspectives. We try to understand what technologies they have, what technologies they will need, and secondly, the organization side, how ready they are. I mean, what is the current level of aspiration for going into this direction? What is the view of leadership? How the organization is currently formed, for example, whether they are into a technology partnership or not. For example, companies in Pakistan who are already working with companies like Toyota and Honda and Suzuki, they would behave differently than companies who are not associated with them or working independently in Pakistan. So organization, how they are organized is very important, or implications for the choices they are going to make vis-a-vis the technology and the future orientation of where they want to go. So the second thing that we studied was the nature of their organization. And thirdly, the environment which is basically happening around those companies, the regulatory environment or banking or other things happening in the energy industry in general. So that is also what we looked at. So we looked at technology, organization, and environment factors throughout the value chain. So that's how we approach this problem of understanding Pakistan's and India's battery electric value chain's current status, potential, and future plans or recommendations. So we collected data from initially from secondary sources, whatever we could get. In Pakistan, it was very limited because the conversation has just picked up in last couple of years, perhaps. But in India, we had more material, and we learned a lot from there. And then we entered into interviews, focus groups, discussions. We had several interviews. We met in Pakistan only. We met 42 executives and top managers, collectively 35 hours long, 18 in-depth interviews, 17 hours long focus groups, and 14 hours long field studies in field visits in Pakistan. So 30. Then we also collected some quantitative data that I think I will not be able to share the findings in this limited time. But I'll share the main insights from there. And we studied Lahore, Karachi, Islamabad, and Gujranwala, that we consider are the main sources of knowledge and manufacturing facilities in this conversation. So here is a layout of Pakistan's battery electric vehicles value chain. So you can see that we have two-wheelers, three-wheelers on left-hand side, and then four-wheelers, buses, and electric cars. Then some knowledge centers, government and entrepreneurship, industry bodies, and technology providers. And then on each column from there onwards, we have a vending industry, we have battery manufacturers, motor manufacturers, controllers, cables, original equipment manufacturers, and one organization which is interested in charging infrastructure as well. And then in the bottom, you can see that we have looked at some knowledge centers such as LUMS Energy Institute, and then some government organizations and chambers and a technology partner. So these are all the people that we have been talking to for understanding the current state of Pakistan's electric vehicle value chain and potential areas and future plans. So here are some of the key happenings. In entrepreneurial ventures, there is a company called Power Electronics Pakistan. So they have piloted a three-wheeler e-rickshaw. The main problem when we talked to them was that they were unable to register their rickshaw with the excise and taxation department. And now I think that this issue has partly resolved. They can do that. So there is on three wheelers, there is this company which is working on. Then on two wheelers, another entrepreneurial company, Jolta. So Jolta is working on two wheelers mainly, and they have three models in line, which is equivalent to which commonly known as 70cc and 100cc and 125cc two-wheelers in Pakistan. So they are targeting vehicles which are going to compete with them. They are developing their own controller and battery management system locally, and although their understanding and their founders are basically coming from knowledge from China and to an extent Korea, so that's where their main sense is coming from. They have developed their own EV kit, which has EV kit is a main thing in two-wheelers particularly, because it enables you to convert an ICE-based two-wheeler right away and very quickly into an two-wheeler, electric two-wheeler, by just replacing the engine with the electric kit and doing some other modifications. So this EV kit therefore is very important. So they are working on it. They are testing it on logistics fleets, on companies like the logistics companies which are doing the delivery things in Lahore and other cities. So they are testing it there. And also they are getting some understanding and working on graphene technology. They are just looking at it, I would say, tracking it in the sense that this technology can be revolutionary in electric vehicles. Then we have this Karachi-based company which is currently focused on importing and making of four-wheelers. So mainly their focus is currently four-wheelers. They are working with some companies in Gujarat and Gujranwala on motor development as well. And then there is another entrepreneurial company, Energy Islamabad. They have made 70cc bike electric, and they are prototyping. They have recently made a three-wheeler also, electric vehicle based. Sasgar Engineering, in the existing companies, existing automobile manufacturers, Sasgar Engineering, they have made three-wheeler and also they are importing now. Recently, they have started importing four-wheeler electric vehicles as well. They are setting up a new factory. I would say that their policy is more liberal and more independent because of less strings attached to them, as they do not have a technology partner or already JV. So they do not have those strings that can bar some of our mainstream auto manufacturers in Pakistan to enter into EVs. So, and I see more hope and perhaps a quicker response also from those companies who do not have much strings with the existing international automobile manufacturers operating in Pakistan. Omega Industry is also another similar example. They do not have, they have a brand called Road Prince in two-wheeler category. So again, I see hope there, but since they are smaller player, they will, I think, be basing on the realization of demand driving their behavior. So they would be hoping that the demand realizes first and then they enter into EVs manufacturing and sale business. So currently they are into ICE-based two-wheelers and they have made a prototype of three-wheeler as well. So their sense was that that government should, or somehow the demand should be there, and then companies in Pakistan will start importing, or and then slowly moving to reverse engineering, and then designing, and then manufacturing will start happening in Pakistan. So their sense is that the demand has to realize first before a company of their size and constraints can enter into this business. Nishat Hyundai recently entered into manufacturing in Pakistan as a result of the 2016-21 auto development policy announced by government of Pakistan. So they have made investments. So clearly we can see that those companies which are recently making investments in ICE-based vehicles, they would capitalize or leverage their ongoing or in the pipeline investments as opposed to entering into electric vehicles. So I think a similar sense prevails in this company as well. Atlas Group is into some of the important areas of the value chain of electric vehicles in Pakistan. So they are into two-wheelers, they are into four-wheelers as well in collaboration with Honda. They also have a battery plant, which is basically lead acid battery plant, and now they are moving into maintenance free also. So, but again, you can see that Atlas Group, since it is associated with Honda, their strategy will be determined jointly, and we'll see a different behavior from Atlas Group, how they approach the EVs market compared to other companies that I've seen before or mentioned before. Now, as far as the component manufacturing in Pakistan is concerned, battery is the key component, as I've been mentioning before. So currently in Pakistan, the lead acid batteries are the main manufacturing units. Lithium-ion battery manufacturing is not there at a scale where we need it to be if electric vehicles manufacturers have to source the lithium-ion battery from them. However, we see that from our conversation with Chief Devu or Atlas, we see that they are looking at this market, that how lithium-ion batteries demand grows in future as electric vehicles come in, and we might see some investments in this area going forward, or perhaps improvement in the lead acid batteries to make them readily usable for electric vehicles. But currently, it's basically lead acid batteries. They are either deep cycle or maintenance free batteries. And only very small entrepreneurial companies are importing battery cells, lithium-ion battery cells from China. They are assembling it and then using them in small, selling them in small sizes and commodity volumes. Then on motor manufacturing, the main hubs in Pakistan for motor manufacturing are basically in Gujranwala. So Gujranwala, we talk to Golden Palm Diamond Motors and Akhlas Motor and Chamber also. So there the sense is that if the demand is there, the industry would be able to in a 5 to 7 years time to move in that direction. Currently, how they are making motors is very basic. Most of the raw material for motor manufacturing is being imported in the form of scrap and then made ready for making a manufacturing motor. So with that type of supply lines, making motors which are usable by electric vehicles is not possible. So that supply line of raw materials as well as the understanding to develop motors which are sophisticated and can give the can meet the expectations of electric vehicles will take time. So perhaps 5 to 7 years. Compared to typical motor manufacturing, I think fan industry's motor manufacturing is more modern and perhaps more ready to take up this challenge of manufacturing motors in Pakistan, because fans motors are more sophisticated than the motors being used in other appliances for which the motors are currently mainly being manufactured in Gujranwala and other cities. Cables seem to be more ready, not an issue so fast cable, for example, we talked to their sense is that they can quickly move on to electric vehicles cables requirements if a demand comes. Controller companies are working on it, and we need to develop that perhaps locally, and battery management system also, because in Pakistan, and similarly, I think India also, the temperature variations on the road are very high, maybe from -5 degrees C or -2 degrees C to 70 degrees C on the road temperature. For that type of temperature, we need to develop battery management systems and controllers. So some of the companies are working on them. LUMS, universities and R&D institutions, some R&D institutions in LUMS, for example, graduate students, this term also MBA students are working on 4 or 5 groups of MBA students, and executive MBA students are working on electric vehicles related projects. Similarly, a few faculty members, including myself, we are working on electric vehicles research from management and business models development standpoint. LUMS Energy Institute is also working from technology and to an extent policy input standpoint. NED Karachi, they are working on motors development. This is an engineering university, so they are working on the technology development of motors. UET Lahore again on motors. UET Peshawar is also working on in general in energy sector and electric vehicles. Some international players are also interested because they see a value in this market. This is Pakistan's market is untapped completely as far as EVs is concerned, and that's where the world is going. So naturally, a potential in Pakistan. So they bring in battery packs, battery management system, controllers, and battery swapping systems, technology, and understanding. And I see some of them are, a couple of them are in mature conversations with a couple of local manufacturers or potential manufacturers of EVs in Pakistan. So the upfront cost is high in electric vehicles, and that is primarily because of battery price. A lithium ion is the way to go, but it's very expensive. So somehow the upfront cost needs to be met or brought down. So some companies are working on it. For example, Sasgar and Energy, they are working on it. As far as the regulatory space is concerned, in the past, basically SROs have been the main tools, but recently, after the the auto policy 1621, which was primarily for ICE based, recently government has announced a two-wheeler and three-wheelers policy in June 2020. So this has given hope to many in two-wheeler and three-wheeler industry. Four-wheelers have yet to see this policy because it's not announced yet. Policy making in this is difficult otherwise also, but quite challenging here as well, because there are some existing players who have made investments in ICE-based vehicles based on our previous policies, and EVs requires a completely new set of investments. So attention on the investment side creates attention for the policymakers also. So how the different stakeholders in this space are going to be taken on board is a challenge for four-wheelers as well. Whereas at the same time, Pakistan seeks to become a 17th signatory of this 30 by 2030 campaign. In this, we need to leverage the statement's ongoing regulations also, and develop energy infrastructure. And energy infrastructure is something that on which currently there is no policy, but I think it has to come if EVs has to government has to go in this direction. So key points, I think I'm running over time, so I'll perhaps quickly just summarize the key points in this whole research. So one is the key components, EV kits, battery, motor, controller. They have different levels of complexities as far as their development is concerned, as I mentioned before. So, but the battery is the key. Battery and battery management system are the key, and also key because we do not have the lithium-ion manufacturing facilities in Pakistan, and also it's 40 to 50% of electric vehicles price or cost of manufacturing. So therefore, it is important to work on battery manufacturing, particularly lithium-ion in Pakistan. Otherwise, we'll have to import. If we import, then upfront cost increases, and then we'll have to work on financing of electric vehicles, so that the upfront cost is met by some arrangements, and this is offset by the operating cost which will realize during the life of EV. So therefore, there has to be some financing arrangement worked out that eases out the upfront investment of the buyer for the benefits it's going to accrue as it runs. So starting, I think the best point for picking up is EVs is two-wheelers, three-wheelers, commercial vehicles, and institutional customers. So two-wheelers, three-wheelers, they can be manufactured relatively easily in Pakistan. There is a large fleet also. I mean, there is a large fleet-based companies also which are using them. So, for example, logistics companies, they can be taken on board for using electric vehicles, and institutional customers can also develop their charging infrastructure and would be willing to invest in it, because they will see a return on investment in a more realizable manner as opposed to individual consumers. So again, on policy, as I mentioned before, there would be a challenge between enhancing demand and versus enhancing demand as well as localization. If you just enhance demand, then you will see import bill going up, and that can only be reduced if you invest efforts in localization as well. In localization, I think we can learn a lot from our previous journey in Pakistan in auto industry. So we can, for example, we can look at the tractors industry. Currently, Miller tractors, for example, is on average 95+% being made in Pakistan, and also it is claimed that this is the cheapest tractor perhaps in the region as well, and by a great margin with some of the competitors in the region and in our neighboring countries. So in that sense, I think we can learn from a tractors industry that how they have indigenized tractor manufacturing in Pakistan. And both government, international technology partners, and these OEMs in tractors industry played very important roles in realization of this deletion and indigenization in Pakistan. So we can learn a lot from there, how to go about indigenization of electric vehicles in Pakistan. I can talk more about it on this tractors and how indigenization has happened there and what we can take away from there. But I think I will stop here and thank you for your patience in hearing what I have to say. I can take on questions now.
Thank you so much, Dr. Saab. It's a wonderful presentation. You covered almost all the aspects. There are some questions, some from my colleagues, some from the participants that we have. So first, we have a question from Babar Siddiq, who's from Pakistan. And he's asking about like recycling of the batteries, the chemical batteries, the lead acid batteries, lithium batteries, plus the other components. So is there any mechanism like which you came across during the study with which we may not harm the environment and life on Earth?
Yeah, so this is a very important point and important consideration because when we say that this is a sustainable technology, we do not talk about only the EV itself. We have to think about how the recycling of its batteries will happen. So that's an important consideration in the whole conversation. And so for lead acid batteries, since the supply lines and the decomposition process and then reusage of the processes is reasonably and fairly, I think, established in even in countries like Pakistan. But for lithium-ion batteries, I think there is nothing much happening in Pakistan for the recycling. And if we have to go into lithium-ion battery manufacturing, then at the same time we'll have to go into the disposal, the how we are going to manage the waste generated by lithium-ion batteries in Pakistan through EVs. So rightly pointed out this aspect. I am not completely privy to the technologies being used for lithium-ion decomposition things. I think somebody from the technical side can respond to that. But I have not come across to the exact technology that is going to be used. But definitely that's an important question from business model standpoint.
Okay, thank you. Then we have another question from Mr. Muhammad Adnan, who's from Pakistan. And the question is that the Engineering and Development Board has approved the electric policy for 2 to 3 wheeler and heavy vehicles. But did they approve for electric car policy like the 4-wheelers? Is there any idea? Because last time when we were almost completing the study, so the policy from Pakistan was almost there. So have you got any idea about this?
So on EV policy, government has been working for last 2 years, I can safely say. And initially this project was introduced by one ministry, and then it moved on to another ministry. And finally, the policy has come out from Engineering Development Board of Pakistan. And the policy currently is just for 2-wheelers and 3-wheelers. The policy on 4-wheelers is still in consideration, has not come out, and we are hoping that it will come out soon, sooner than later, because I have been hearing feedback on from 4-wheelers that and there were some concerns also that why policy for 4-wheelers is not coming out. So there are people who are really waiting for EV policy for 4-wheelers as well. Good that we have it now for 2, 3-wheelers, and we can make progress on that. And right now, for the as far as the OEMs and others who are associated with this value chain.
Okay. Due to shortage of time, we will skip some of the questions. So do you have questions?
Nice. Okay, let's move to next.
So thank you so much, Jaja Saab. I mean, it was a wonderful presentation. Thank you for your time and for being with us here today. Thank you.
Thank you, Dr. Tanveer. Thank you, Dr. Shoaib. Everyone, thank you very much.
So, ladies and gentlemen, our next presenter is Dr. Harita Saranga, who is a professor at the Indian Institute of Management, Bangalore, IIMB, India. She has been awarded IIMB Chair of Excellence for her contribution to research and teaching excellence at IIM Bangalore. She also chairs the doctoral program at IIM Bangalore. She is a fellow of MIRC Academy, Exeter, UK, and a recipient of the TE Philby Research Fellowship. She has published several articles in top-tier international journals, has also co-authored a book titled Reliability and Six Sigma, and has written many cases and book chapters. Over to you, Dr. Saranga.
Thank you very much. Dr. Tanvi, let me just share my screen. Yes. Thank you very much, Dr. Shoaib Ahmed, Dr. Tanvi, and Dr. Said Zahoor, who was whether he is present in this, but who also collaborated with us on this study, and Dr. Shakil Jaja. Great presentation, Dr. Shakil. And thank you very much for this opportunity, SARC Energy Center. Basically, what I plan to do during this session is that since Dr. Shakil has covered a lot about the study and how we went about the entire research process of the study, I plan to essentially focus on India. You already got an overview of how the battery electric vehicle industry is evolving in the world. You also got an overview of what is happening in Pakistan. So I will focus completely on India. The overview of the presentation looks like this. First, I'm going to focus on evolution of battery electric vehicles in India and what are the schemes that Indian government has introduced to encourage adoption of BEVs. And then we will look at the current developments in various segments of auto industry, because just like Pakistan, India too has different maturity levels as far as EVs are concerned in different segments. So I will take you all through industry segment wise. And then we'll take a look at the battery charging infrastructure. What are the plans, strategies, and investments that are going into charging infrastructures, as well as the BEV supply chain. And finally, we'll have some time for Q&A, I hope. Interestingly, the evolution of BEVs in India started way back in 2001. So when GM came up with their first EV, in fact, India had their first EV as well, by one of the pioneers of electric vehicles in India, Mr. Chetan Maini. He was from Indian auto component industry. His company Maini Precisions used to and even now supplies auto component parts for ICE-based vehicles as well as aerospace industry. He was very passionate about electric vehicles, and he actually collaborated with one company in the US for technology, and he came up with Reva, which was very popular in India in terms of its name, but not in terms of adoption. So although our first four-wheeler was introduced in the market in 2001 itself, the total number of PVs sold every year is abysmally low, as you can see. It's actually 3,400 in the last financial year. Similarly, if you look at the two-wheeler segment, again, the first electric two-wheeler was introduced in India in 2006 itself, but the latest numbers, if you see, the last financial year, only 152,000 two-wheelers, electric two-wheelers were sold in India. Now, just to put these numbers in perspective, the total number of two-wheelers sold, this is including EVs and traditional ICE-based vehicles, was 2.7 million. Sorry, 17.4 million, the two-wheelers in the 2019-20. So that puts things into perspective. So 152,000 EVs in 17.4 million electric two-wheelers. Similarly, if you're looking at PV segment, the last financial year, the total number of PV sold in India were 2.7 million. Out of that, only 3,400 were electric vehicles. So you can see that the numbers are quite small in terms of percentages. And in terms of electric buses, there were only 600 buses sold in 2020. I think the passenger carrying buses, I think there were about 45,000 to 50,000 buses sold in India last year. So only 600 electric buses. So why such slow progress despite having the first models introduced in India, so many years ago? One of the major reasons is actually customers' reluctance to shift to EVs. The customers, it's a new product and they're always worried about, obviously, the cost first, and next the range of the vehicle, and also the charging infrastructure. So the adoption by the customers was so poor that even manufacturers were not very willing to introduce new products. And it's like, a chicken and egg problem. So if you don't have very many products in the market, customers also feel reluctant to buy new products in a new segment. And since there was so little demand, manufacturers were not ready to introduce new products. So this chicken and egg problem was exacerbated by lack of infrastructure, because obviously EVs need their own charging stations and or battery swapping facilities, which were completely absent in India. So that didn't help the cause. And like how other countries have done, uh, there was a need for government incentives to push adoption of EVs, like what China did or even US did, and most of the European governments that Dr. Shakil mentioned in his presentation. If you see whether it's Norway or Germany or UK, so most of these governments started giving incentives, both fiscal incentives and economic incentives, in terms of direct cash benefits, reduction in taxes, and other freebies for manufacturers to actually support EV production. This was necessary because the cost of battery was so high, which was contributing 40 to 50% of the cost of the total vehicle. So that upfront cost, unless we subsidize that upfront cost, no matter which customer, which country, it seems like the EV adoption doesn't happen automatically. So what changed in recent years? Actually, falling prices of lithium-ion battery. You all have seen this graph already from Dr. Shakil. This has helped significantly, right, in recent times. If you look in 2010, the cost of battery per kilowatt hour was $1,200 US dollars, and within 8 years, you see that it has come down to $200 per kilowatt hour. And we expect to see, as the battery technologies make more progress, because there is a lot of R&D going on across the world on different chemistries in terms of reducing the cost further, and also dependence on lithium ion, where China has the dominance. As more and more R&D happens and more new technologies, new battery chemistries come about, the expectation is that by 2025 or so, the cost of battery will come down to less than $100 per kilowatt hour. So this reduction in cost has definitely helped India's cause. And so government began pushing for adoption of EVs in India. Of course, there were also a couple of more reasons for this push by the government. One of them is India's huge dependence on imported crude oil. As many of you may already know, 85% of our crude oil needs are basically met from by other countries through imports, and we spend anywhere between 100 to 120 billion dollars, depending on the oil price, every year on these imports. And this is only going to increase as more and more people start buying cars, and other needs for oil increase. So this was one reason why Indian government started looking at EV adoption very seriously. The second reason is that pollution. The greenhouse gas emissions have been increasing significantly in Indian cities, and one of the major contributors is the automobile emission. So in fact, one of the recent studies has shown that 22 out of the 30 most polluted cities in the world belong to India. So these two reasons mainly encouraged Indian government to start looking at incentivizing EV adoption. And basically, as you can see, although it has been in discussion since 2012 or so, finally, the faster adoption and manufacturing of electric vehicles in India, the FAME policy came into existence in 2015 with some fiscal incentives, and there was an outlay of 895 crore rupees for phase 1 of the FAME policy. And this, again, the objective was, as Dr. Shakil had mentioned, India was signatory to the Vision 30 at 30 policy. So 30% of automobiles sold in India should be electric by 2030. That was the objective. And as part of this policy, mild hybrids were also encouraged and subsidized, along with strong hybrids, plug-in hybrids, and pure electric vehicles. In fact, the phase 1 FAME policy also gave some subsidies to BEVs with lead acid batteries. In fact, the REVA, the first four-wheeler, in fact, it's called quadricycle, also was a lead acid based vehicle when it was introduced in the beginning. Then there was also subsidy for two-wheelers. Of course, these were more of motorcycles with 40 kilometers per hour range and 60 to 70 kilometers of range with a full charge, got subsidy of 22,000 rupees. Then came the phase 2 of FAME policy. This was in 2019, April. And this, in fact, gave the biggest push for EVs in India. As you can see, an outlay of 10,000 crore for FAME 2 policy. The subsidies for both buyers as well as producers. And the buyers got nearly $1.4 billion in terms of subsidies through this FAME 2 policy. And another 1,000 crore was set aside for charging stations, creating the infrastructure basically. The objective was to create 2,700 charging stations across metro cities and, smart cities and so on. But there were some riders, as Dr. Shakil was mentioning. It does make sense to create demand, but also to, it is essential that we actually also focus on localization, because otherwise, instead of oil bills, import of oil bill, we will have import of CKDs, SKDs, and, fully built vehicle bills, replacing the oil bill. So with that in mind, Indian government has announced that this, you can receive subsidies as manufacturer as part of FAME 2 only if you are sourcing minimum 50% of the components locally. So the objective is very clear, that we want to create and establish and and run supply chains for battery electric vehicles and other hybrid vehicles locally. And they had a very specific target. As you can see, there was a lot of focus on electric buses. So this 10,000 crore rupees is to support 7,000 odd electric buses, 20,000 odd strong hybrids, 35,000 electric cars, 500,000 three-wheelers, and 1 million two-wheelers. So the numbers speak for themselves. Again, as in Pakistan, in India too, the focus was on two-wheelers and three-wheelers, and electric cars are there, but 35,000 is actually nothing if you see, right? It's just there for the sake of name. And the government's objective is essentially to facilitate, public transport, as well as that's where the electric buses and three-wheelers come in, and also encourage two-wheelers, electric two-wheelers. So, and there were again additional incentives for adoption of BEVs in India, other than the 10,000 crore in FAME 2 and FAME 1. For example, GST rates for EVs have been reduced from 12% to 5%. In fact, some of the ICE-based vehicles tax ranges anywhere between 28% to 40%. So basically if it is an EV, then you incur only 5% GST. Similarly, EV chargers also incur only 5% GST, and income tax rebates of up to 1.5 lakh rupees has been given to customers on interest paid on loans to buy electric vehicles. So there are tax rebates in addition to the direct subsidies. And for manufacturers, to encourage them to get into EV supply chains, for instance, if you are manufacturing solar electric charging infrastructure or lithium storage batteries, then you can avail investment-linked income tax exemptions and other indirect tax benefits. Also, an annual subsidy of 700 crore will be allotted for manufacturing of batteries for electric vehicle and mobile phones. Again, this is keeping in mind that we want to encourage indigenization, localization within India. In fact, there is talk that this 700 crore has been increased. In fact, there is a talk that nearly 4.2 billion rupees will be set aside for supporting the battery manufacturing and cell manufacturing in India over the next, several years. Then the government also created a company called EESL, whose objective is mainly to procure electric vehicles from reputed manufacturers and distribute them across government departments. So essentially, the idea behind this is similar to what is being done in Shenzhen, for example, or some of the European countries. Because the cost of EV, the upfront cost of EV is so exorbitant, creating demand is difficult. But at the same time, unless there is a minimum scale for manufacturers to make investments into EV production is also difficult. So to solve this problem, this was started by China and many other countries followed, and India is also following now, is to actually place orders of large scale on one or two companies so that they actually find it viable to make investments into EV production. That's the whole idea. So this 10,000 EV procurement and creation of EESL so that you actually create some scale economies for manufacturers is in that direction. Similarly, Delhi government approved 1,000 electric buses to be used in Delhi's public transport system, and other states like Maharashtra, Karnataka, and UP and so on are also following suit. Andhra Pradesh is the other state government which is seriously looking at it. So there are central government subsidies and schemes, plus individual state governments are also chipping in with their own schemes and with their own subsidies to actually make this EV dream reality. I'm going to take you through different segments of the auto industry now, because they function very differently and the level of maturity is also very different. So it's good to actually look at it segment wise. Why two-wheeler industry is in much focus? One of the main reasons is because 25% of the pollution in India is being created by two-wheelers. As I mentioned, in the last financial year, the total number of two-wheelers sold in India was 17.4 million units. In fact, the year before that, it was 21 million units. So two-wheelers make up a significant chunk of automobiles in India, and therefore also contribute to significant chunk of pollution in India. So it makes sense that if you are trying to target pollution through EVs, that then you try to replace two-wheelers, ICE-based two-wheelers to EVs. So that's one reason why two-wheeler industry is in much focus. FAME 2 policy, as I mentioned, has started giving 10,000 rupees per kilowatt hour of battery capacity for two-wheelers, which is almost 50% of the total battery cost. So this significantly reduces the upfront cost for the customer. And in fact, what we have seen is that the EV two-wheeler sales have increased significantly last year. This year, sorry, not last year, this year, 2020-21, after COVID has hit India, a lot of youngsters, in fact, are buying EV two-wheelers. So it seems to be working, this strategy. Charging infrastructure for two-wheelers is not too difficult to create. In fact, only a plug point is needed for AC charging at homes. Once you charge, and especially in cities, two-wheelers don't commute more than 20-25 kilometers in one go. So it is actually, charging is not a major concern when it comes to two-wheelers. You can always charge at home after you come back at in the night, or you can, if you're taking two-wheeler to offices, then in office also, if they create some plug points, you can do slow charging there. And fast charging, in fact, there are vehicles like Ather Energy vehicles have designed their vehicles in such a way that 80% of the battery can be charged through fast charging within 1 hour. So that is another option for long drives. And the industry leaders actually predict that the capacity of two-wheelers should reach 3 to 4 million by 2024-25. So what is driving the two-wheeler sales in India? In fact, both it also applies to four-wheeler. The cost differential. While the upfront cost of a EV is nearly twice as that of an ICE-based vehicle, the operating cost is much less. I'm sure all of you know this already, but I'm going to give you some figures. This is a study that was conducted to compare what is the cost of operating a two-wheeler for 2 years and a four-wheeler for 4 years. EV versus ICE-based vehicle, you see the cost difference here. So for a two-wheeler ICE-based vehicle, it costs 36,600 rupees to operate it for 2 years, whereas an electric vehicle costs only 3,400 rupees. A four-wheeler for 4 years operating it costs 3,06,640 rupees with ICE-based engine, whereas it costs only 44,000 rupees. In fact, I was going through some feedback, customer feedback a few days ago of a four-wheeler. In fact, it's an SUV purchased by a customer, and he was basically saying that it costs him less than a rupee per kilometer operating an SUV. So you can imagine the cost advantages of owning a BEV. Of course, the upfront cost is much higher, but I think the total life cycle cost would be much cheaper. Plus all the other advantages of less pollution and less noise and so on. Now, three-wheeler industry. In fact, India has a significant three-wheeler industry, and I'm sure Pakistan has as well. The last mile connectivity is what the three-wheelers essentially contribute to. And in India, it's worth $42 billion. And it is largely led by e-rickshaws and auto rickshaws. In fact, India has already more than 1.5 million battery operated e-rickshaws. And this market and this growth in e-rickshaws has come about without any help from the government. This is completely led by demand. So most of these e-rickshaws are put together from imported kits from China, and most of them are lead acid battery operated e-rickshaws. In fact, because it is an unorganized sector, it is very difficult to keep track of what is going on in this sector, other than the fact that there is huge volume of them present on the roads. In recent times, because of FAME 1, FAME 2 policies, and because there is so much push by the government, The aggregators are playing a key role in adoption of e-rickshaws, lithium-ion based e-rickshaws in metro cities like Delhi. And one of the key players in this market is Smart E, which currently has about 1,000 e-rickshaws, and it has plans to increase its fleet size to 10,000 and expand into 9 new cities in the next 18 months. And Smart E, in fact, sources vehicles from Mahindra and Kinetic Green, and energy solution providers basically are Panasonic, Exicom, and Sun Mobility. And they went ahead and experimented a lot in the Indian market in terms of what kind of charging infrastructure is needed, and whether a battery charging should be done or a battery swapping should be done, and so on. And similarly, Ola Electric is the other company which is exploring this space, the three-wheeler space, along with the two-wheeler and four-wheeler space. And they have plans to deploy 1 million EVs by 2021. Of course, COVID has come and it has put brakes on a lot of these plans, so we have to wait and see what happens. They started this with deployment of four-wheelers and e-rickshaws in Nagpur and Delhi, and now they are introducing electric two-wheelers in Europe and Asia. So they have acquired app scooter from Netherlands, and they are using this app scooter to deploy two-wheelers as an aggregator of two-wheelers. And as I mentioned, they are trying to figure out still in this space what is the best business model in BEV context. And most of the growth in this space is actually led by the market demand, because in cities like Delhi, there is a good metro connection for long distances, but short hauls, that is from home to metro station and metro station back to home, there is no good public transport available. So the three e-rickshaws are the ones which are in high demand, and they are basically exploiting this opportunity. As I mentioned, there are different business models people are exploring, and here is an example of solar e-rickshaws. These are hybrid. There is a motor that converts the solar energy into electricity and helps the rickshaws to go much faster, almost double the speed than if a man was operating them. And you can see that these e-rickshaws were actually donated by a company to IIT Delhi campus, and they are trying to see, because there is no regulation right now by the government for hybrid rickshaws. They are hoping that some regulation would come about, and this would in fact make it really green, because one of the controversies of electric vehicles in India as well as across the world is that are they really green? Because how the electricity is produced at the end of the day, if it is produced using fossil fuels, then what is green about it? That is a debate. Now, these kind of solar-based solutions will make them really green. So a lot of innovation is going on in this space, the three-wheeler space. Here are some examples of the companies that we have interviewed during our study, and what is the technology they are adopting in terms of their entire supply chain. So you can see that in the electric two-wheelers, we have some startups like Ampere Vehicles, Aether Energy, Mflux Motors, Electrotherm, and so on. But there are also some established companies like Hero Electric and TVS Motors, who actually have the first and third, ranked players in terms of market share in the ICE-based two-wheelers. So Hero Motors actually has its own subsidiary called Hero Electric, which is manufacturing EVs, and you can see that most of them import cells but manufacture their own batteries. They assemble them together in-house. Except for Ampere Vehicles and Electrochem, who import the entire battery. Battery management system, again, most of them have their own design, which is quite interesting because in the two-wheeler space, it seems there is most R&D technology development happening in India. These are, most of them are designed by the companies themselves rather than importing them. Motors also, you can see that Ather Energy has designed and developed their own motors and motor controllers, the entire drivetrain, and Ampere Vehicles also makes their own. Electrotherm also designed and developed motors and controllers in-house. This is where most of the indigenous technology is playing a role. Whereas in the electric three-wheelers, you see that most of them are the battery, when it comes to its lead acid battery, and the motors and so on are imported, motors and controllers. And this is basically importing of kit, the entire kit, and putting them together. That's what is happening in the three-wheeler industry. Next, let's look at the four-wheeler industry, what is happening here. So Mahindra and Mahindra actually purchased the Reva by Chetan Maini in around, I think, 2012 or so, and they bought the technology, they bought the entire company, the rights for the vehicle, and they started developing it. And today they have two passenger vehicles in the EV segment, E-Verito and E20, and they have invested significantly. 1,000 crore is what is committed as of now, but more is on the anvil, and they're very serious about this business. So they have a separate unit which is very seriously looking at both fully built vehicles as well as the powertrains. So during our interview, they said that they are looking at scale economies, and they're very committed to this space, and they think that unless you have scale economies, it is very difficult to survive in this market, and therefore their strategy has been to invest in large scale, especially in the powertrains, and supply these powertrains to other OEMs. So what they say is that anyway, the other OEMs are importing mainly from China, so they might as well source it from us. And we have our own patented technology, so we can create powertrains for two-wheeler segment, three-wheeler segment, four-wheeler segment, and we can provide them this entire powertrain kit so that they can locally source from us, and that will give us the scale economies that we need. And so they have this two-pronged strategy of not just creating vehicles, fully built vehicles in all two-wheeler, three-wheeler, and four-wheeler space, but also provide the powertrain to other OEMs. So this seems like an interesting business model to look at for Pakistan. If there is a company which is serious about EVs, I think they should closely see what Mahindra and Mahindra is doing, and maybe there are some lessons they can learn. Tata Motors, the other indigenous company, is working closely with its Jaguar Land Rover unit in UK to design electric vehicles. They already offer a Tigger compact sedan for taxi aggregators, and recently launched Tata Nexon SUV for final consumers. And we have to wait and see what the reaction is going to be, as the numbers are very low as of now. Similarly, Hyundai Motor Company, which is the second largest automaker in the PV segment in India, has introduced the Kona SUV in July 2019, and this was the first automaker to introduce an SUV in the EV segment in India. And MG Motor, which is actually owned by SAIC in China, has introduced recently MG ZS EV in India, and Mercedes-Benz is launching electric SUV EQC soon in October, which is next month. And Nissan Motor also has plans to launch BEV Leaf in India this year. Of course, again, these plans are a little iffy because of the COVID and because of the low sales in the automobile industry in India, but these plans are there. If not this year, they will introduce next year. So that's the story in the four-wheeler industry. And then electric buses, if you look at Indian government is focusing on converting public transportation into electric vehicles because again, this is to reduce pollution in the cities, and also because the government has control over public transportation. So there is a company called Olectra, which is a JV between India and China's BYD. As Dr. Shakil mentioned before, BYD is supplying electric buses to North America, Europe, and Latin America. They're also supplying electric buses to India. So they already have more than 100 buses flying in various cities, and recently they bagged a contract for 765 e-buses from various state governments. Tata Motors is one of the first domestic company to develop electric buses, and they also won orders from different state governments and cities. And JBM Solaris and Ashok Leyland are the other two major players in this segment. For example, 133 electric buses have been deployed across Pune city in the first phase of its e-bus program. So that gives you a feel of what individual cities and state governments are trying to do. Depending on the level of pollution and the focus they have on pollution reduction, individual cities are going ahead with their own e-bus programs. And obviously, buses need charging, and if it is public transportation, all the more you need the range and power to charge within short span of time. So there is a lot of innovation going on there. People are exploring both charging as well as battery swapping solutions in this space, and companies like Ashok Leyland and BHEL and so on involved in this space. Here are some examples, of current sourcing practices of electric car and bus makers in India. You can see that electric cars, Mahindra is the largest player. They are importing the cells, but making battery packs in-house. Again, BMS is their own design, whereas motors is imported. Again, controller is own design. Similarly, Tata Motors is importing and sourcing from their own group company, because they have now the Land Rover in UK. They are able to make use of their technology and their connections. Hyundai Motor is importing their batteries and sourcing BMS and motors and so on from Korea. And MG Motors, the Chinese company, is basically again sourcing from their own parent company. So basically what we see here is that other than Mahindra, which is a domestic company and has developed its own technology, acquired Reva, and has the patented technology and so on, other companies are basically sourcing from abroad the technology and the battery packs. And similarly in electric buses, Ashok Leyland, Olectra, BYD, JBM Solaris, all of them are importing batteries or cells, and they are sourcing most of them from abroad, and except for JBM Solaris, which is own design, but then it's a Solaris is a foreign company. They have their own technology, and hence they are making use of that. So not much domestic indigenous technology is present in the cars and buses, unlike two-wheeler, where we see that there are several companies like Ather Energy who have done significant R&D and creating their own patented technologies. Looking at BEV supply chain and how much of it is happening in India, just to give an idea, basically you have a cell which has an anode, cathode, electrolyte, and separator. And several cells put together creates a module with electric connectors. And several modules are assembled together to create a battery. And there is a battery management system which manages this entire battery pack using electrical connections. Now, if you look at India, an ICE-based vehicle versus a BEV, ICE-based vehicle engine, the combustion engine essentially has over 400 parts, which are replaced by 17 parts in a BEV powertrain. So you can see that there is a significant reduction in number of parts and the need for servicing when you shift from ICE-based vehicle to a BEV. So if you look at India, India only has cell-to-pack manufacturing, that is modules perhaps they can put together, and they can also assemble batteries, but cell manufacturing is missing in India. And right now, the cell-to-pack manufacturing plants have a capacity of 1 gigawatt per annum. But based on the projections of how much capacity we need, about 10 gigawatts capacity by 2023 and 30 gigawatt capacity by 2025 is what the projections are currently. So we clearly need to make investments into creating this capacity in India. The existing OEMs basically are importing batteries from China, Taiwan, and Korea. And when we spoke to them, during our interviews, most of the companies are like, it's not a big deal, we can make investments into this space. The only issue is the demand is not materializing. So if the demand does not materialize, then making investments, because in a cell manufacturing plant or even battery assembly plant, you need to make significant investments to establish a plant. So it's not easy and it will be sunk cost. So unless we see some demand, it is not realistic for us to make investments. This is what they say. Having said that, here are some of the investments that are planned into battery plants. You can see that there are 12 different companies which have made plans to create assembly plants. Only 3 companies, BHEL, HBL Power Systems, and Tata Chemicals, which are highlighted in red, are the ones which are actually looking at lithium-ion cell manufacturing. All other companies are essentially looking at assembly of battery modules and battery assembly. And charging infrastructure, as I mentioned, the Indian government has earmarked 1,000 crore for setting up 2,700 charging stations. So the plan is that we must make available at least 1 charging station in a grid of 3 by 3 kilometers. So, and major highways connecting major cities on both sides of the road should have a charging station at an interval of about 25 kilometers each. Indian government has also roped in the public sector oil companies like BPCL, HPCL, and Indian Oil to create charging infrastructure in the country. So because these are the companies that are going to be affected, they are the ones which have petrol bunks right now. And if we are going to switch to electric vehicles, then obviously they also need to switch, and it makes sense for them to start making the investments right away. So that's the idea behind this. And even private players, like for example, SAIC, they are tying up with other energy companies to provide charging stations, because they want to create a comfort in customers' minds that if necessary, there are charging stations. In fact, SAIC has already set up charging stations in their dealerships in each of these 5 cities, and they are also exploring setting up of more charging stations. Sun Mobility is another company. This is actually owned by Chetan Maini. After selling off his Reva company to Mahindra, he started Sun Mobility, and he is very serious about creating the charging infrastructure, and he is working with the state and central government agencies as well as fleet aggregators like Smart-E to create battery swapping infrastructure, because he believes that battery swapping is the solution way to go to encourage BEVs in India, along with charging stations. Again, there are several academic and research institutions which are participating in the supply chain. One of them is SECRI, based out of Tamil Nadu. They have developed their own technology, and they are planning to set up a factory to produce batteries for electric vehicles with 100 crore investment. And they claim that their batteries are going to be even cheaper than Chinese prices. We have to wait and see, of course. And they are getting technical help from Fraunhofer Institute of Germany to improve battery performance and to localize, because Indian conditions are different. So we also need technologies, battery technologies that can withstand the Indian conditions. So they are doing R&D with planning to do, they are doing R&D already, but planning to work with Fraunhofer Institute to improve it. Then from IIT Madras, there is a professor, Ashok Jinjumwala, who has been very instrumental in nurturing several startups and groups to develop new batteries and EV models in India. In fact, Aether Energy was started by a couple of his students from IIT Madras, and they're doing pretty well in terms of the sophistication of technology and the vehicles that they have manufactured. Similarly, there is a Center for Battery Engineering and Electric Vehicles in IIT Madras. It's a startup, and it is collaborating with several manufacturers and trying to find cost-effective BEVs for India. So before I close, I just want to share that while Indian government has been trying to do many things to promote EVs in India, there are some pieces missing still. For example, the regulations that we have seen in Dr. Shakil's presentation, in terms of saying that you must have, if you're an OEM of certain size, you must have at least certain percentage of vehicles must be electric vehicles. That is one regulation which is related to fuel economy. That is not there yet in India, but is there in China as well as in many other countries like US as well. So that is one. And infrastructure support policies, for example, buildings, parking lots, etc., mandating that they must keep some plug points and some space for EVs, that I think will go a long way in promoting EVs. Similarly, for example, China, we know that has made significant investments in R&D to promote EV technology in China, and it has paid off. We saw that nearly 94% of EVs manufactured in China are by domestic companies. So while we are requiring localization to provide subsidies, 50% localization, I think that is not enough. Governments must make use of all kinds of trade and non-trade barriers to promote EVs and local production by domestic companies in India. So there is still lots to be done, but I think we are going in the right direction. Thank you. I'm open for questions now.
Thank you so much, Dr. Harita. I mean, it was a very well composed presentation. You covered all the topics at a given time. So there is a question for you, that given the simplicity of electric vehicle drivetrain as compared to the conventional ICE vehicles, and in your opinion, how difficult it will be to train the local car mechanics? So we are talking about the general car mechanics. Like you mentioned the case study in IIT of these solar rickshaws. So what do you think about that? What is your experience with that?
Well, it depends on what is the level of sophistication in the vehicle. So what I understand is that there is huge variability in electric vehicles, BEVs, in India, and I'm sure in Pakistan as well, and in China as well. So there is, at the minimum sophistication, the lowest sophistication level, you are talking about just replacing the ICE-based engine with powertrain, electric powertrain, right? So there, I think it is much easier for mechanics to manage such low sophisticated vehicles. But then you also have vehicles like, for example, Ather vehicles. If you see two-wheelers, we are talking about two-wheelers. In two-wheelers, Ather has their own patented technology, and there is a huge amount of electronic content. So it almost, they call them smart vehicles. So it's almost like, the way it interacts with the customer is equivalent to like managing an iPad or a computer, right? So it provides you all those features to make phone calls and to give you signals when something is going wrong with the vehicle. And it also provides customization for each individual customer based on their driving habits and the way they are managing the vehicle. So if you are looking at such a sophisticated vehicle, then obviously the regular mechanics who are dealing with your ICE-based engines will not be able to work on those kind of vehicles. So you will need different type of servicing mechanisms and training for those kind of vehicles. So it depends on what vehicle you are looking at.
Different innovative business model.
Sorry, can you repeat that? I lost you for a bit.
Okay. You mentioned different innovative business models for BEVs, and we saw some models as well. So what do you think, how feasible the battery swapping can be as a business model in SAARC region? Considering the reluctance of people to adopt EVs, like the market here in South Asia is more like cost driven, given the buying power of the people. So what do you think the battery swapping as a business model?
Well, I think again you have to look at which segment. I think battery swapping works, and in fact is necessary if you are looking at public transportation and aggregators, right? Like for example, you're talking about buses. And if you're looking at a very heavy traffic area where the bus has to do multiple routes and it doesn't have enough time to do the charging, right? You can do, if it is stopping overnight, you can do slow charging, but in between, if the range is not sufficient, then you will have to do swapping. So in India, we are exploring that. In fact, some public buses like in Delhi and so on, they have already created swapping stations. So battery swapping is needed there. Similarly, if you're looking at taxi aggregators, right? So there again, you know, if it is heavy traffic area, they don't have, the drivers don't have time to wait and charge their vehicles for an hour or two. Even if the fastest charging we are talking about is minimum 1 hour, they may not have that kind of time. And creating charging stations, and the vehicles need to be parked there, when you imagine, visualize how this is going to work, how much space do you need to create? In countries like India, in such densely populated cities like Mumbai and Delhi and Bangalore, we don't have that kind of space to let the cars wait while they are being charged for hours on end, right? So again, for aggregators, because that there is one place where they can go and they can swap and they can immediately get on, it can happen within 5-10 minutes, the swapping, right? So it makes sense for them to have swapping. But for consumers like you and me, I don't think we need to worry about battery swapping. In fact, I would say the kind of charging that happens right now and the way we the range that we need for a BEV, I think we can just do it at home. You need to create a plug point at home and in your garage, so that you just charge it overnight, and only when you're doing long distance travel, maybe when you stop in a restaurant to have your lunch, you then plug it in a charging station for an hour or half an hour and charge yourself. right? So you don't need to have a battery swapping requirement for individual customers. But aggregators, yes, you do need it. And I think it will come in Asian countries. Yeah.
Thank you so much, Dr. Saranga, for your wonderful presentation and your time. It means a lot. Thank you so much again.
Thank you very much. I appreciate the opportunity. Yes.
Okay, dear participants, we would now move to the last presentation of the day. We have Mr. Peenal Satish Mehta with us, who is the Associate Director, CRISIL Research India. Mr. Peenal has been associated with SEC in many activities as a consultant and has vast experience in renewable energy systems and BEVs. We will also be joined by Mr. Pramit Paul. So over to you, Mr. Peenal.
Dr. Tanvi, thank you so much, and good afternoon, everyone. Good afternoon to Dr. Shoaib Ahmed also, and thank you very much, for this opportunity. Just to again, associate with SARC and Energy Center on multiple, emerging areas, and very specifically, on this topic on, how the ecosystem of battery electrical vehicle manufacturing, what are the challenges, what are the opportunities in this space. So very briefly, we'll be covering this into two parts. Of course, the earlier speakers have Dr. Harita and Dr. Shakil. They've already covered into much detail. The authors, they've covered much into details while interacting with different players. However, just to give our views, further on this space, we are going to cover in two parts. One is the generic, what is happening globally, what are the challenges, opportunities, what is happening globally, and again, not taking much into detail because Dr. Harita has already covered. However, few aspects that we feel in India can also help the entire audience. So these are the two parts that we'll be covering. The first part, will be covered by my colleague Pramit Pal, and India-specific study, I'll be covering that in the later part. So, just to move on, and before, we move on to this very specific study, I just, briefly introduced about the CRISIL research. So, CRISIL research, we are India's foremost provider of ratings, data, research, and analytic and other solutions. There are different aspects, as you can see. However, we are from CRISIL research, wherein we provide independent study and providing rich insights and perspectives of Indian markets. We cover different aspects of the research. Economic research, we have a big economic research led by Dr. D.K. Joshi. He is our chief economist. We cover more than 86 industries across the value chain, and that's part of our industry research. In addition to that, we also provide services across funds and fixed income research, wherein we provide help insurance firms and AMCs basically providing valuation services on the security level. And in addition to that, we also have the customized research, which basically covers the bespoke research, the client-specific objective-based research, which are part of customized research. So, I just briefly introduce, what kind of services that we cover. So across value chain, so there are basically four broad buckets. One is business planning. So if a particular player wants to enter into any specific space, we provide business planning support. We look at also, strategic initiatives, maybe in terms of commercial due diligence or maybe post-investment monitoring, and also, helping the client in market entry strategy. In addition to that, we also undertake the competition benchmarking, what's happening across the value chain, what competitors are doing in the market, what strategy they are following as far as, expansion and value additions are concerned. And also, we undertake feasibility and viability studies across. So in brief, this was just the introduction on the CRISIL research side. So I'll now request, my colleague Pramit to take over and, explain more about the global BEV manufacturing across the value chain. Thank you.
Sure. Thank you, Peenal, for the introduction and setting the context for the study. Yeah. So, good morning and good afternoon, everyone, based on wherever you're watching this webinar from. My name is Pramit, and I am associated with CRISIL Research for the last 3 years or so. I work as under the position of Senior Research Analyst, and I specifically work with the customized division of the energy team in the company. So yeah, moving on to the topic. So, as highlighted by my colleague Peenal, the main report has already been prepared on BEV manufacturing, and it already, speaks about the overall topic at large. Further, deep diving into the two SAARC nations, namely India and Pakistan. So, what we would be doing in this presentation today is we would be providing an independent take on the subject, wherein we will be speaking of the major drivers or factors which we believe can influence BEV manufacturing in a country. So what we believe and we understand is that BEV manufacturing majorly hinges on three pillars as seen in the presentation or in the slide. The first one being the overall readiness status of the EV industry. So the uptake or the attractiveness of EVs in a nation needs to preclude a strong ecosystem of BEV manufacturing is what we believe. So therefore, demand side growth in the form of EV adoption across vehicle segments is predominantly important. This we believe can help, flourish domestic manufacturing, and with the right set of policies and supply side interventions, this can easily be scaled up. Also, we believe that it is important that EV makers, be it domestic or global, they consider a nation conducive enough for setting up a base for EV manufacturing. The second pillar is what we believe is the access to global supply chains. For example, as of now, around 50% of automotive components which is used in EVs, with the major component being batteries, differ from the components which are used in ICE vehicles. So the ability to source the raw materials which are required, as well as honing the domestic R&D space to cost effectively manufacture BEV vehicles in-house, that would be a very important key to success for any country who is who intends to set up BEV manufacturing in their country. The third pillar is what we believe is pertaining to the regulatory and policy perspective taken by the respective federal and state governments to improve the BEV manufacturing ecosystem in different nations. So this would require the right set of tools, which goes beyond is what we believe giving subsidies or SOPs to players. Therefore, indigenous skill development or allocating funds towards research studies is very important. So in this slide, we have highlighted the major stakeholders in the BEV manufacturing ecosystem. In the EV manufacturing space, it majorly begins with the R&D section, and then moving on to raw material mining, which is the key to manufacturing battery cells, and subsequently battery packs. Moving up the chain, there comes the component manufacturers who specialize in producing key EV components. And then further up, we can find the battery pack assemblers, and then finally the EV manufacturers who source the different components and batteries from separate vendors or who produce them in-house. Also, a key actor in the chain are the digital technology providers in the form of telematics. Finally, once an EV is manufactured, it rolls out of the factory and moves to the dealership. Also, on the after sales side, which is also an important component of the overall BEV manufacturing ecosystem, the different actors tend to be the swap operators, the aftermarket component makers, and the maintenance service providers, who are the key stakeholders. So all in all, we believe that these are the major players in the BEV manufacturing ecosystem in a country. Moving on to the next slide, where so this is where we are specifically highlighting on the first pillar, which is the readiness status of industry or EV industry in specific. So the chart on your left specifically talks about the fact how EV market has been growing steadily across the world, driven by the developed economies. And the evolution of green mobility has spawned across geographies, which is driven by a federal support, better products by manufacturers, strong private investments, as well as improved EV sales in the form of end-use demand. The entire global stock of EVs has already surpassed around 5 million in 2018 end, and if I'm not wrong, it has surpassed even 6 million by 2019 end. In Asia, China has been the biggest contributor to EV sales, while in the Europe, countries like Germany and Norway leads the pack. As far as EV manufacturing is concerned, what we see in the table below, the China leads the pack, which is followed by Germany and USA. So global automakers have all flocked to China to set up, EV manufacturing facilities to cater to China's burgeoning market as well as the global demand. Moving on to the next slide. Yeah. Uh, Here we speak about the access to global supply chains, which is the pillar 2. So here what we see is that the uptake of EV technology appears to be progressing faster than expected, with industry forecasts routinely being revised upwards. The rapid uptake of EVs will see an emergence of new supply chain connecting previously unrelated industries like mining, battery manufacturing, and automotive supply chains. These would continue to be interwoven going forward. As we see in the slide, the major stages of battery manufacturing for EVs includes mining of raw materials, chemical processing of materials, and in the subsequent slide, we would talk about cathode and anode production, and then finally in the fourth step being the lithium-ion battery manufacturing. So as seen in the charts, China has secured a dominant position in all of the major 4 stages. So as far as mining is concerned, graphite and nickel is being mined heavily in China. Also, although lithium is majorly being mined from brines of Argentina, Chile, Bolivia, and some parts of it from Australia as well. Whereas, in the case of cobalt, close to around 70% of global supplies, they originate from Dominican Republic of Congo, followed by Russia, Cuba, and Australia. However, what China lacks on the the raw materials mining front, it holds huge advantage as far as the chemical processing comes into picture. So China hands down holds advantage in all of the major chemicals, while USA has had some amount of share as far as nickel and cobalt is concerned, whereas EU has continued to lag behind with respect to mining as well as chemical processing. Moving on to the next slide. Yeah, where we speak about the third and the fourth stages of the battery metal supply chain. So as we see on the anode side, owing to close to 100% unilateral market share in graphite processing, it gives a clear edge to the country as far as anode production is concerned as well. Also, as far as lithium-ion battery manufacturing is concerned, some of the largest companies in the world belongs to China. Although manufacturers like Tesla, they have begun producing cells and batteries in USA, the sheer scale advantage still rests with China. As a matter of fact, if you see in the table below, close to 101 of 136 lithium-ion battery plants are coming up in China. Yeah, moving on to the next slide. Yeah, so what does this mean for the global supply chains of EV manufacturing, especially in the battery segment? As can be seen that one country holds competitive advantage across most of the major BEV manufacturing stages. The monopolistic advantage can have a negative impact on other nations, with one country having high bargaining power as well as pricing power. The European Union or the EU, they have already sounded alarm, with the European Commission warning that over-reliance of imports of critical raw materials can threaten to undermine the crucial industries. In fact, based on one of their own estimates, is that in order to meet the climate neutrality goal that was set out by the EU in 2018, it would need up to 18 times more lithium and 5 times more cobalt in 2030. Also, the forecasts are expected to be around rise to around 60 times more lithium and 15 times more cobalt in 2050. But what we believe is that battery technologies and chemistries are evolving with every passing day. Only a few days earlier, Tesla has announced that they would no longer be using graphite in anodes, and they would rather transition to other materials like nickel and manganese, which is more commonly available and easy to extract. So what we believe is that going forward, the dominance of supply chains will shift and may shift to other regions like the US or the EU, or in fact other developing economies might also jump into the race like India. However, innovation in battery technologies and a country's position in the overall innovation for the shift, these would actually hold a key to success. Moving on to the next slide. Yeah, this is the third slide, rather the third pillar, where we talk about the regulatory and policy incentives given out by the different nations pertaining to BEV manufacturing. So in this slide, we would specifically be looking at some of the key, regulatory interventions done by the US or the different federal agencies to further their e-mobility goal. So what we believe is that it is important to adopt policies supporting the adoption of EVs so that technology reaches mass market commercialization as quickly as possible. So government investments have happened in the US with respect to EV based R&D, manufacturing, and jobs being created in the country at large. Several stimulus funded grants and R&D activities have been encouraged by different federal agencies, including the Department of Energy. Loan support was provided very early on to the early movers of EV technology in order to incubate, build, and scale up on manufacturing capabilities. Companies like Tesla were also some of the key companies who have received huge amount of loans from the government, and that helped them to actually scale up their business operations, and and they have actually made a name in the global EV space as of today. Moving on to the next slide, where we would shift our focus to the European Union. The EU has been improving the uptake of EVs with countries like Netherlands, Norway, Germany, and Denmark, who have seen a surge in sales over the last decade or so. Several policies have also been undertaken to give incentives to EV buyers in the form of tax breaks or subsidies, etc. The region has predominantly been a leader in ICE technologies, with the big shots of companies like the Volkswagen, BMW, and so on and so forth being born and brought up in the country. However, EU has been a bit late to catch up to the EV race. The transformation of the supply chain has been happening with new suppliers emerging with every single day. Governments of several countries have been investing in new age companies who are dedicated to EV automotive research, but large economies of scale are yet to be achieved in the EU, and different countries and the European Union are indeed taking very proactive steps to actually move up the value chain. Moving on to the next slide, where we would shift our focus to China. So there's a crucial trend in global, EV manufacturing, that over the last few years, China has rapidly established itself as a global leader, leaving the Europe and other regions behind. Some of the largest EV manufacturers are the newer Chinese firms. Japanese and US firms were the early movers, but only Tesla has been able to, currently being the leading manufacturer in the global EV market, so to say. Chinese companies have proliferated and grown rapidly, driven by the country's strong industrial policy. A key to that, instrumental growth was a policy or a policy priority which was, charted out by the country, which goes by the name called Made in China 2025 industrial policy, that envisages a significant, global market share for 10 high-tech industries, including EV manufacturing. So in that framework, the Chinese government, both in the central as well as the local levels, they have strongly supported the manufacturing of EVs. Different measures have also been taken, like setting out ambitious EV targets, which requires car makers to meet certain EV quotas in their production. Generous fiscal subsidies were also given to EV manufacturers based on the EV's driving range per charge to foster innovation. The government has also spelled out several requirements for international car makers to manufacture EVs in China to access the market. So this has also helped, spawn domestic companies, and also helped blossom even new high-tech companies in the country as well. So these measures has had a kickback effect, and it has kickstarted the nation to achieve a dominant position in the EV manufacturing as it holds today. The subsequent slide specifically pertains to India, where we would be looking at what is the competitive advantage of India, and how it has where India lies as far as the global supply chain of BEV manufacturing is concerned. So I would request my colleague Peenal to actually take forward the subsequent slides.
Pramit, are you there?
Yeah, so Dr. Tanveer, a request if you can make Pramit presenter here.
Okay, please make him the presenter. Pramit, you can carry on now. You can share your screen, please.
Okay, I'm just trying to, yeah.
Yeah, the screen is visible now. If you could please move on to the slideshow mode. Yep, thank you.
Yeah. So thank you, Pramit, for that brief context and also the introduction on the global side, covering different countries. Moving on to the India on this very specific slide, what we've done is we've tried to benchmark the country with some of the global leaders, and also see where the e-mobility lies today and how is it poised to grow over the next decade or so. So this is our outlook based on our own assessment in India very specifically. So presently, if you see, as highlighted in the table above, the penetration of EV across all vehicle categories is very low, which is, below 1%. And going forward, as highlighted earlier also by my other, friends who have authored the study. So, going forward also, the kind of penetration that we are also expecting is in the two-wheelers and three-wheelers. And very specifically, if you look at the three-wheelers and two-wheelers as compared to ICE, the two-wheelers very specifically on the e-scooter side, not the motorcycle segment, that's going to have the penetration. So, by fiscal 2030, the bus segment, which is majorly operating under state transport units, as well as in cab aggregators, we see a major shift towards EVs as cost of acquisition reduces. As also highlighted earlier, the battery prices is expected to go down below 100, which will actually, bring down the overall cost of the basically owning and operating the battery-based electric vehicles. However, the traction from the personal mobility side, basically the passenger vehicles, will be majorly, hit because, or there is going to be a low penetration because of lack of charging infrastructure. Though we are talking about slow charging and fast charging even today in India. So, for example, one of my colleagues, though he has purchased an electric vehicle, in a year, he was only able to drive for 1 year, right? Because he had to actually, ask his neighbors who's at the first floor to, charge the infrastructure or basically electric vehicle in absence of, the common or public charging infrastructure, which is not available in this very specific case. Also, overall, the population as far as the electric vehicles is concerned, overall till 2030, we expect that it to reach around 80 million, with e-rickshaws or e-two-wheelers basically contributing around 87% of the overall population. So moving on to the next slide. What we've done is also, though Dr. Harita has, covered in detail what are the regulatory and policy scenario. However, in brief, on regulatory side, there are several policies which have been brought out by the government in order to, provide thrust to EV sales and EV charging station adoption. All the key policies include, the NEMPP, basically the National Electricity Mobility Mission Plan, the faster adoption and manufacturing of, hybrid and electric vehicles in India, FAME 2, very, in the last year, which was announced. Government also been, keen and taking certain steps to promote and encourage BEV manufacturing. And, mostly this has been in the form of either lowering the taxes on EVs or, by raising custom duties on EV parts importing into country. This will actually, promote the domestic manufacturing in India. As far as the taxes are concerned, government believes that these benefits will allure global investment to set up a shop. And very recently, the GST on EVs have been reduced to 12%. In the fiscal budget announcement also, the basic custom duty basically on completely built units of EVs has been proposed to be raised to 40% from 25%, which will actually promote a semi knockdown as well as completely built in India electric vehicles, and it will actually promote this very specific segment. The custom duty on import of electric vehicles also on the completely knockdown form has also been increased from 5 to 15%. So these are all the measures which are proposed to push the domestic manufacturing of electric vehicles. So moving on to slide number 16, in India, of course, we do have federal and state level mechanism wherein they all, there are certain concurrent constitutions. So, several states like Maharashtra, Karnataka, Andhra Pradesh, and very recently Delhi, they've actually formed the electric vehicle policy, which is, providing push to adoption and increasing the penetration of electric vehicles within respective states. As a part of, BEV manufacturing, so states like Gujarat, Telangana, Andhra Pradesh, Maharashtra, and Tamil Nadu, they've actually proposed, giving off certain incentives in the form of, certain free land or capital subsidies or tax concessions to, the potential BEV manufacturers. So in all, along with the federal government or central government, the state governments have also been providing certain incentives. Moving on to the next slide. So on this slide, we've considered some of the opportunities and challenges, that will actually impact the manufacturing of BEV in India. The large opportunity, in fact, in India itself is on, as a developing nation with all, overall automobile demand growth of around 8 to 10% year-on-year basis, which we've seen in the last decade. So there is definitely an opportunity. However, there are certain regulations and policy which has actually impacted in past few years. However, there lies a very good opportunity for India to shift to EVs with the right set of policy push and attractive pricing proposition. Because consumer market is a very cost averse consumer, and that will focus on the cost and basically cost of owning as well as operating the electric vehicles. Also, with the country having a large base of ICE automotive component manufacturers in India, it provides a huge opportunity for them to, shift over or to transition towards building EV parts within India. So, with the right set of product innovation, maybe technology tie-up with global players, the business intervention, the industry can indeed, support the BEV manufacturing in years to come. However, on the flip side, though there are opportunities, there are certain challenges also which India faces. The biggest challenge is, in fact, that EV demand in the country is yet to propel. Therefore, the large-scale BEV manufacturing at this point of time will be a challenge. So this was also a point which was, undertaken or which came out while Dr. Harita, undertook that study. Scaling and large-scale production will definitely, impact the overall cost, and it will bring down the cost and therefore affordability to the end use consumers. Furthermore, the country does not have access to the materials as highlighted by Pramit. China is playing a very dominant role across the raw material space. So for example, lithium, nickel, manganese and cobalt, which are used in manufacturing of lithium batteries. Therefore this can be a challenge, and this is actually proving to be a challenge as far as the domestic manufacturing is concerned. However, of late, there are certain talks in India by different companies trying to secure long-term mine output, so that they also have control over the raw material, and they can make raw material available at the cost which is affordable to the end use consumers. Also, one more challenge is there. There is a lack of proper ecosystem for developing and manufacturing EVs in India due to lack of demand. The import components such as lithium-ion cells, electric motors, and other electronic parts are mostly imported by manufacturers. Therefore, this reliance can be done away with domestic manufacturing. So these are another opportunities, and of course a challenge that high reliance on import, which is actually pushing down the domestic manufacturing in India. Overall, what we believe is, the country has a large set of challenges. However, this can be changed to opportunities with the, right federal support and increased power sector participation. And of course, the driving force behind this will be the overall penetration and the demand from the end use customers. So, with all, in brief, we were trying to, cover the opportunities, challenges, overall. And moving on to the next slide, basically what we see is presently global EV, or basically BEV manufacturing, is tilted heavily in China. However, USA and EU, they are actually investing a lot in EV technologies. China, though, again has a dominance in the supply chain as well as the raw material is concerned. So that also will play an important role, and which going forward, how the other countries will adopt to this kind of scenario needs to be seen. Globally, EV growth is expected to remain strong. The new innovation in battery technologies, the scaling up of manufacturing capacities, and the countries, in turn achieving the economies of scale will further reduce the cost, as I highlighted earlier. And therefore, overall the increased penetration and the domestic manufacturing ecosystem in each of the SAARC member nation, relying or less relying on the imports, will actually promote and also help growing growth of the EVs in respective SAARC member nations. So that's it from our side, and me and Pramit will be happy to take up the questions if you have further. Thank you so much.
Thank you so much, Crystal, for this very nice presentation. I mean, that was a good summary of the whole world, given that we came to know about Pakistan and India in the first two presentations. So I have a couple of questions for you guys. The first question is that you mentioned the materials, and you also mentioned the Tesla, what is happening with Tesla and stuff like that. But as supercapacitors have high power density but low energy density, so how do you foresee their use in electric vehicle of future in extending their range? Talking about specifically the supercapacitors.
Well, indeed, supercapacitors are in vogue right now, and a lot of technology innovations are happening in that front. Every new age companies, be it Tesla to the smaller companies across the globe, they are toying around with these kind of technologies, looking at different battery chemistries, different battery densities, in order to improve the driving range, as well as the bring down the costs. So this is a dichotomous situation that everyone is facing. And although I would probably not be able to answer your question from a technical perspective, but all in all, what we believe is that these kind of technologies will indeed play a major role in improving the driving range, as well as the technology improvement as far as batteries are concerned. Yeah.
Okay. So then, I mean, another question which comes into my mind, and which was asked by some of my colleagues here as well, is that you mentioned throughout the presentation, and in fact we saw that in the first two presentation as well, that China is quite dominant in almost all aspects, whether it's material or manufacturing or anything else in terms of the BEVs. So what to do for localization of the industry in the SAARC countries? How to utilize these indigenous resources that these countries have?
Well, to be very honest, the SARC nations, do not have a very strong point as far as the mining requirements are concerned. I mean, they do not have access to the raw materials in house. But you know what SARC nations can do, what China has also been doing. So China, if you see, they do not have huge mining capabilities of cobalt or lithium or manganese, for that matter of fact. What they have done is that they have taken unilateral position as far as the chemical processing is concerned. So they have taken control over the mines. They have, you know, because they are a huge nation, and they are having huge end use demand. So the different Chinese manufacturers, EV manufacturers, I mean, they have entered into long term contracts with these mine operators in different countries. So I believe different countries, including SARC nations as well, that also that needs to be looked into. So specifically speaking, India, some of the countries, they are also in final stages talks with some of the mine operators in Bolivia or Chile, if I'm not wrong. So we have to accept the fact that yes, we do not have access to the raw materials within the country, but what we can do is that we have to be proactive in acquiring them from abroad, and then we can chemically process it in house and build up the cells and then battery packs, rather than directly importing the battery packs from China or any other country.
I mean, it was a very wonderful presentation that we have. Thank you for your time. It means a lot to SEC. So with this, I would now like to invite Deputy Director SEC for his concluding remarks. Over to you, sir. Thank you.
Thank you, Tanveer. Dear participants, let me begin by thanking the presenters of this video conference for sharing their knowledge and taking us through the details of this research, and also for their excellent response to the queries raised by the participants. We came across many interesting and useful information through their presentations. I believe many good experiences have been shared and good lessons have been learned. I would also like to pay my deep respect to all the participants for their enthusiasm and positive participation in this video conference. I hope what all we have learned in this conference will help us in discharge of our duties and responsibilities as energy experts. It will also contribute in cleaning and strengthening the regional transportation and energy sectors. Moreover, please be apprised that your feedback and the recommendations for any further improvement in this research report would be highly appreciated by the SARC Energy Center. Finally, I would like to thank my own colleagues for smooth conduct of this event. With this, I officially announce the end of this video conference and wish a prosperous and clean future to all fellow South Asians. Thank you for your attention. May God bless all of us. Thank you. Thanks.